just whether the um, slide is visible to all.
Yes.
Yes.
Yes. So one name. I come to the the concepts and the like qualitative variables after some moments. But before that, we have to make some conceptions on. Firstly, when you are doing some research, that is what we are doing. First, we try to observe something. That is some relationship or some research questions in your mind, and you have to do what you are trying to do. That is, you have to observe something. So that is what type of observations, if you asked, that is, for example, that is how people consume, how they spend, how they earn, etc., blah, blah, blah. And these kind of things, first we have to observe. So on the observations, we try to construct a causal relationship. That is, if this is happening with these variables, if this is happening here, what will be there? What will be its repercussions? What will be its effects? So causal relationship is a very important thing, and we try to construct in research, that is quantitative research and as well as the qualitative research, that this such kinds of causal relationship. So when you deal with such causal relationship, it basically depends on data. That is the informations, the observations we have to collect, and on to hypothesizing your causal relationship. That is, it basically depends. The causal relationship basically depends on observations. Is the sharing is on? It is going on? It is visible to all?
Yes, sir.
Okay. So, but sometimes it is happen that suppose you relate a thing like X with the thing like Y, then you do not know, but you do not get the ideas whether X is influencing Y or Y is influencing X. That is the direction of causations. This is an important thing. You build up some causal relationship and you get some informations, but it is also another tough thing, that is in which directions they are related. Which one is influencing the other? Which one is first influencing the other? It may be multiple type of causations will be there. So, for example, suppose I am taking one example from economics, social science. For example, that is consumption causes income, or income causes consumptions. That means if I have to make some consumptions, then I require some income. And if I have income, or otherwise, that is, if I have income, then I go for some consumption. So whether consumption causes income or income causes consumptions, this is the direction of causation. So first we go to causations. That is the causality between the variables, between the thing what we are hypothesizing. So we assume, suppose for the time being, we assume there is income causes consumptions. If there is income, so then a part of the income will be spent on consumptions. So income causes consumptions. Suppose this is the relationship. So from where it comes, that is this such type of causality, like income causes consumptions. From where it comes, it generates from some economic or social theory or any other things. It may not be the income consumption. It may be the other type of relationship. For example, you consider the aging and the aging of an individuals and its behavior behavior towards real world. So there is also another type of causality. So purely it generates from economic or social theory. So a theoretical background behind what I am trying to say, that a theoretical background will always play active role behind every causal relationship, or what we behind our research. So then we have to construct some. In case of social science research, you have to construct some mathematical relation. But I'm not going to the deep of these kind of things. That is the second step is the mathematical relation. So we formulate the relations as it is framed by our ideas. That is income influence consumption. If I assume that income causes consumptions, so mathematical relationship, how we write this? We write this by this way. That is consumption is equal to some parameter like alpha plus some parameter which is multiplied with income. That means you find that from this relationship, if income is 0, then consumption is alpha. Because an individual he has to live without income, and but he has to spend something on consumption, because for to maintain his living life. That is, if income is 0, then there will be some consumptions. But if income increases, then obviously consumption changes. So the beta into income parts will come. This is the mathematical relationship, and we consider it as y is equal to alpha plus beta x.
Sir,
So this is a purely
disturb করছি।
consumption income relationship.
স্যার আপনি
Yes.
ফার্স্ট স্লাইডেই আছেন এখনো? Right.
Yes, I am on
ঠিক
the
আছে।
first slide, means
হ্যাঁ ঠিক আছে, মানে অনেক সময় মুভ করে না তো সেই জন্য।
move করছে তো।
এখন ডামি ভ্যারিয়েবলসই আছে।
Then I'll 1 minute just. I don't know. Is it visible?
Yes, sir.
Yes, sir.
Yes. I don't know why it is. Now look, just take some. That is. Is it visible now?
Yes, sir.
That is the first step, and the second step. That slide it is.
Yes, sir.
Yes.
Yes, sir, but it's not in the presentation mode.
It not.
It's not in the presentation mode. Slideshow is not on, sir.
Not in the presentation mode.
না
What
ওটাকে
is it?
স্লাইড শো করে দিন, তাহলে বড় দেখতে পাবে। সেই
না, আমি স্লাইড শোই করছি তো।
সাইড বারটা আছে বলে হয়তো প্যান বারটা সাইডে আপনি করুন আবার।
এখন কি স্লাইড শোতে আসছে না আসছে না?
দাঁড়ান, আপনি শেয়ার করুন।
1 minute. Just 1 minute. শেয়ার করছি এটা। আচ্ছা, ইন্টার স্ক্রিনটা করে দিবি। Now it is come. Look.
Yes,
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 yes.
The first step and the second step, the mathematical relation, these are coming, na?
Yes, yes.
Okay. So what we are telling that there is a consumption income relationship, and it is a purely mathematical relation. That means you framed a hypothesis, that is consumption income causes consumptions. Then we frame this idea. That means there is some relationship here. For the simplicity, we assume a linear relationship, but it may not be true that everything is linear. It may be non-linear. So consumption depends on income. This is a mathematical relation. Now, as income increases, consumption increases by amount what? That is the amount beta. So what is the importance of alpha and beta? I'm telling you that is alpha is the intercept term and beta is the slope term in the relationship income consumption. But that is not important here. So third step. Now the question comes that if this is a relationship, now listen, one important distinction between the research of pure science and research of social science. What is happening actually? In case of pure science, like suppose zoology or botany or physics, chemistry, they are doing it within the lab. And what we are doing? we are doing in the society. Our research is in the society. So what is the difference? That what they're doing in the lab, the pure science people, they can control the environment. They can control the environment. But what we as social scientists are doing, that is, we have no control over the environment. So you have to collect the data, and the data are highly influenced by the environment. So if I go back to my previous slides, that is, consumption is equal to, we assume that consumption depends only on income. But in reality, what is happening, that except income, there are multiple number of factors are there which are influencing consumptions. In reality, it is happened. But we, the social scientists, assume that consumption is only depends on income. So there is something we are missing in the mathematical relation. There is the influence of other factors which are not captured here, which are not considered here in this relationship, that is, consumption is equal to this alpha plus beta income. So what we are doing, we go to what is the remedy of such kinds of things? That is when what we are doing in the open environment, where the consumption is influenced by the several other factors except income. So how we capture this? Then we go for a statistical relation. Then we go for a statistical relation. And what is the basis? That is, this is the need by which we are converting such mathematical relations into a statistical relations. What is the need? Because we are not controlling the environment. It is not possible for us. So mathematical relationship, which is appropriate within a laboratory, within a room, that gives you the exact relation. But the statistical relation is the relation which is environment friendly. That means covering the environment, you get the relation. So you have to consider a relationship between consumption and income, covering all the other factors which are influencing the consumption except income. So you have to capture those factors. You have to consider the relationship between consumption and income, considering all influences of all other variables. So what is the mathematical relationship gives us? That is, consumption is equal to alpha plus beta income. That is the exact relationship. But in reality, it is not true, because consumption is influenced by the other factors. So what is happening? That is, it may be there are the several factors like wealth, taste and preference, blah, 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 several factors which may also influencing the consumption. So the statistician, they are doing what? They are considering the model, that is, they frame the model by such a way that where what we are trying to relate income with consumption, it will be there, and there may be some other variables influences which are also taking it by a separate way. They are also bringing this item into the relationship, that is, consumption is equal to alpha plus beta income. So how it is? So otherwise, if you follow the mathematical relationship, that is, consumption is equal to alpha plus beta income, you know that it is not true, because there are so many variables, other variables. We have some ideas like wealth, taste and preferences, but there may be some factors which we have no ideas. So what we are doing, that is those variables may be of taste and preferences, like those variables are not even quantitative form, they may be qualitative form. So how we have to influence such relationship? So we need a statistical model. This is the need of a statistical model. And what is the need? How we frame the need? That is the relationship. Suppose Y stands for consumption and X stands for income of the individuals, different individuals from which we collect the data, we incorporate another term, that is the white noise. And this is identified as UI. And UI is what they are assumed, that X is income and Y is consumption, and alpha beta is the parameters related with these two variables. And there are some the influences of other variables which are also influencing YI. Those are identified by the term UI. So this is the beauty of the statistical model. What is the need of the statistics? What is the need after mathematics? Why we use statistics? And UI is such an unobserved part, which is unobserved. But how we catch this unobserved by our quantitative techniques or qualitative techniques, that is the beauty of the statistical model that I will discuss later or in other sometimes, because if you get some basic econometrics books, there are the several mathematical techniques. That is how we have to deal with UI. But UI is that influences of other variables over the consumptions except income. So this is the beauty of the statistical models, and which is known as unobserved effects. UI is termed as unobserved. Now it becomes complete. Now the relationship between income and consumptions becomes complete, because if we include UI, then we have considered the possibility of full form of a consumption function, because YI represents the consumption, XI represents the income, and UI the influences of other variables on consumptions. Okay, it is. So sometimes it may be represented in our analysis, in our research, that is, we consider XI, that is the income, to explain YI, that is the consumption. But there are the several other factors. So we are not considering those factors. So UI is termed as omitted variables, which are except income, which are influencing consumptions. So this UI may be termed as omitted variables, and this is considered as a stochastic or random error term. Why it is stochastics? Because in case of considering the UI, there are the several other independent variables which are influencing the consumptions. They have some randomness, they have some probabilities to come into these relations. They have some specific probabilities to come to influencing consumptions. For example, what I am giving you idea, that is, suppose consider two persons. One is very rich, another is very poor. So to the poor person, taste and preference is not very significant. Its probability is low. But to a rich person, taste and preference is important. So if in your data, you collect the individual's data, if he is a rich person, then the variables like taste and preference have some influences in terms of its probability. But for poor, it has some separate probability to come into the choice set. So the variable UI or the unobserved effects is stochastic. That means it has some random components. That means it is attached with some specific probabilities. So does it mean that we don't know anything about UI? What I'm telling earlier, that UI is a bunch of variables, bunch of influences of other variables except income. Some of them may be in our knowledge, some of them may not be in our knowledge. So does it mean that we don't know anything about this unobserved effect? No, it is not a complete black box. What do we know? That if these UIs, these unobserved variables are behave by such a way, it behaves by such a way that if we take the average of these unobserved effects, that is equals to 0. That means Something you just consider, that is considered by such a way that some of the influencing other variables influences consumptions positively, and some of them are equivalent negative amount they are influencing consumptions. So the average becomes 0. And it is not a statement, mind it, there is a mathematical proof, but I am not going to that mathematics. This is one thing, and this mean, this average of the UI is written by as expectation, because expected value is nothing but the average. So it is given by expectation of UI given what is given, that is what is not considered in the UI, that is given the income, that is Xi. So when income is given, the mean value of all other individual variables, that is equals to 0. And not only this, the unobserved variables is distributed. Distributed means what? What is the meaning of the distribution? Distributions means the properties of a variable. Like what properties? Properties like descriptive statistics, properties like mean, median, mode, variance, skewness, kurtosis. These are showing the distribution pattern, how it is distributed. So the first property of this unobserved factor is that its expected value is 0. And second thing is that this UI is distributed normally with the expected value 0 and a constant variance. That means, what is the meaning of the variance? Variance of a variable shows its spreadness, how it is spreaded. Because if you I think you in your undergraduate level or postgraduate level, you know that what is the variance, that is the actual value minus the mean, its square, and then summing of this, we get the variance. So that means the distribution, that is the distribution of the variable values, that is Xi, from means is a constant, that is sigma u squared. It is here. So unobserved effects, that is the UI, are distributed by such a way that its mean equals to 0, and it is distributed normally. Is a specific distribution. I'm not going to that detail. You know that there are several types of distributions, but it is a distributed normally. Normal distribution is a concept, that is, it is symmetric. Both sides area are equal, and a constant spreadness, that is the sigma. So, but today our research is mainly dealing with the qualitative variables. That is I am explaining this. That is what is the meaning of the first assumptions or first property, that is expectation of UI given Xi is equal to 0. That is the stochastic error. What is stochastic error? Its mean value is 0, and UI follows the normal distribution with mean 0 and constant variances. But consider what up to this we are discussing, that is about consumption and income, a basic relationship. Now, when you go to collect the data about the consumptions and about the income, you get the numerical values from the individual. What is his consumption and what is his income? You collect the data. But if it is not such a quantitative data, what will happen? So if it is not such a quantitative data, if it is qualitative, then what will happen? So suppose we consider except income consumption relationship, what we consider, that is wage of the individuals, what they receives is depends upon their gender. Suppose wage is influenced by the gender. If he is male, he gets a specific wage. If she is female, then she gets suppose lower wage. What is happening in our society, normally in our society, which actually today's these are not prevails, but some days they go 10 years, 15 years. This is happening. The females are getting lower wage in compared to male for the same kind of job, more or less same kind of job. And the social scientists defined it as a gender discriminations. That is, in case of wage, if the females get lesser wage, then there is a gender discrimination. So if you think about this model, that you go to collect the data about wage, you get the numerical values, you get the mathematical values of wage. What is the wage? 500 rupees, 600 rupees. But when you collect the information about that individual gender, your reply will be either it is a male or it is a female. So there is no numerical value. Either he is a male or she is a female. So how we have to deal with these kinds of things, these kinds of relationship. Then, so in this model, what we consider that the salary of a daily wage labor depends upon gender. So a male daily wage labor, what is our basic theory? That is, a male daily wage labor will get more salaries than female, suppose. So we go to the data collections, then you collect the data, we hypothesize the relations, that is, a male daily wage labor will get more salaries than female, and we go to the data collections. So what we found in our data collections, we get the wage rates, different wages from different individuals, and we get that some wage laborers are male and some are does not. That is, they are female. So this is our data set. So gender here is not any quantitative variable. It is an attribute. It is an attribute, and that is no numerical value is there. It is non-numerical. So how we run the regression? How we run the relationship? How we get it? And this is you don't care about this. This is the normal relationship. If you consider that for two quantitative variables, if wage is a quantitative variables, and suppose the gender, consider the before relationship like consumption income, consumption is suppose Y and gender is suppose X. Then how we calculate the beta? This is the formula. That is the formula of beta, how we get it. It is actually today's, it is not calculated by you because software is given this result to you. So now, if there is no software, then you have a data set on consumptions, that is Y, and you have a data set on income, that is X. So both are numerical, so you can calculate Xi minus its mean and Yi minus its mean. So then you get the beta hat. Now, in this relationship, that is wage is equal to alpha plus beta gender, you get the Yi, because wages are given to you, so you can calculate Yi minus Y bar. But what is the Xi and X bar? These are only stated as male and female. So you cannot get beta hat. How we define beta hat? How we calculate, estimate our slope parameter, that is beta hat. So it is not possible, that is such type of formulation is possible when the variable is quantitative in nature. So what is the remedy? We get the information here like male and female. So we write the equation, we derive the equation by this way. That is, wage is equal to alpha plus beta di plus Ey. Now what is di? Now the question comes, what is di? That is, we know di is gender. So we frame di as an artificial variable. And how we framed it? The artificial variable is 1 or 0. Suppose, for example, you consider the attribute is a male gender. So you put the value when he is male, you put the value di as 1. And when she is female, then you put in place of di is equal to 0. So once means, so in your relationship, 1 means what? The presence of the attribute. Presence of the attribute, and 0 means that is absence of the attribute. That is the female. So if this is the thing, that means we frame di by such a way that is, if it is 1, We consider what? We consider male gender as an attribute. So the characteristics is present, and 0 means the characteristics is absent. So then it is called a dummy variable, artificial variable. There are the several other names also. That is the indicator variable, qualitative variables, binary variable, dichotomous variable, categorical variables. These all are under the dummy variables. Okay, it is. The screen is working now. Sharing.
Yes, sir.
Okay. So DI is identified as 1 or 0. That is on the basis of in terms of the characteristics is present or it is not, and it is called a dummy variables or qualitative variables. So, but why it is 1 and 0? That is clear to us. Consider just the previous relationship, that is wage is equal to alpha plus beta di plus ey. That is for the individuals who are male, for them di equals to 1, and for the female di equals to 0. So what is the implication of 1 and 0? That is wage, when di equals to 1, we get what is the wage? That is alpha plus beta di, and if di equals to 1, then it becomes alpha plus beta. And that is when it is 0, it becomes only alpha, because beta into 0, that is becomes 0. So wage is only alpha. So look, when di ranges from 0 to 1, wages also ranges from alpha to alpha plus beta. That is, if di is equal to 0, what is the wage? Alpha. And if di equals to 1, what is the wage? There is alpha plus beta. So as the di ranges from 0 to 1, then wages also ranges from alpha to alpha plus beta. So what is happening here? As the gender is a categorical variable, it observes two values, which is constructed by mind. That is, it is 0 for the female and 1 for the male. I can transfer the wage into two categories. One is alpha, another is alpha plus beta. And you know surely what is alpha? Alpha is the wage for the female, because di is equal to 0. And what is alpha plus beta? That is the wage for the male category for whom di equals to 1. I am not coming to that point, but this is the meaning. So qualitative variables here in this example of two categories, male and female, but it may be more than two categories. How? Suppose I construct a regression like this, that is wage is equal to alpha plus beta into caste. So caste, there are the several categories like general caste, scheduled caste, scheduled tribes, other backward class A, other backward class B, and some minorities. So there may be several categories. So here we consider two categories, that is the male and female, and we implement one artificial or qualitative variable. But it may not be always hold, that is that there may be more than two categories are there. So qualitative variables may be more than two categories. So this is one important. I'll come to this discussion later. Now look, what is the crux of the thing? That is, in case of our gender wage relationship, what we get? That gender are of two categories. That is, one is male and female. So what are the number of categories? 2. And how many dummies you incorporate? How many qualitative variables you incorporate? 1. That is di or d. So look, number of dummies, that means number of qualitative variables, will be 1 less from the number of categories. What will happen if we introduce 2 dummies for the 2 categories? One is for the male, another is for the female at the same time into the equation. That is quite interesting. I will come to that answer at some end. But you have to remind this: the number of dummies will be one less. That means, for example, in your caste example, if there are the suppose general caste, scheduled tribe, and suppose other backward castes. So there are the 4 categories. So how many dummies you have to introduce there? One less. That means you have to introduce 3 qualitative variables. Instead of 4, you have to use 3. We can use 4, but there are some that is some special cases. I will not discuss it. This is a general thing, that the number of dummies will be one less from the number of categories. Is it clear to all up to this? If you have any questions on this, it is okay.
Yes, sir.
Okay. So first, now I am going to that kind of discussions like male wage and female wage. So first consider the earlier discussed, what we have discussed one, that is the one qualitative variable is there in the model. So one qualitative variables is like this, that is which I discussed, that is wage is equal to beta 0, that is the intercept term, and the beta 1, that is the into gender, that is the slope term, into the gender plus some unobserved derived terms. So if I replace the gender, because gender has 2 categories, male and female, so you have to use 1 dummies as per our blue line based signal, that is 1 dummies. So it is beta 0 plus beta 1 di plus ey. Now what is di? We construct the qualitative variables by such a way that it is 1 for the male and it is 0 for the females or otherwise. You have to the fashion of writing for the qualitative variables is by such a way that is 1 for male and the 0 for otherwise. So what is the interpretation of this 2 term? What we are doing in the regression analysis, that is on the basis of some data which may be quantitative or qualitative type. For example, here wage is a quantitative data and DI is a qualitative data. So what will be the interpretation of beta 0 and beta 1? That is what is the interpretation of you can consider, that is if there is nothing like DI, then wage is only expressed by beta 0, and if it is something by DI, then the wage is expressed by beta 0 plus beta 1 DI. So that is which is related with DI, that is called the beta 1, that is the slope term, and the which is not related with DI, that is the beta 0 term, that is called the intercept. So if we take the mean values, you just consider your data set. If you take the mean values of wage, that is this equations. Here the PRF means population regression function. I am not going to those meaning what is the population regression or this kind of thing. These are the ideas of econometrics. So if you take the mean values of wage, considering the male and female, then what you get, that is, you cannot calculate it because there are the 2 groups of the people. One is male and another is female. That is, for someone DI is 1 and for someone DI is 0. So if I take the expectation of wage, given DI equals to 1, so then put DI is equal to 1, what will be the wage? That is beta 0 plus beta 1. And that is what, that is the male for male mean wage. Because why for male? Because DI is equal to 1 is considered for the male. So it is the average or the mean wage for the male people, male category. That is the mean wage of male category. And similarly, if we try to find the expected value of the wage given DI is equal to 0, that is the beta 0, and that is for the female mean wage. And that means the mean wage for the female category. So you find the difference. That is, the mean wage of the male category is beta 0 plus beta 1. as our equation is framed, and the mean wage of the female category is beta 0. So if I am asking you that by what amount the males are getting wage more in compared to the female, that we take the difference of these two, and that is the beta 1. So now go back to the that equation, that is wage is equal to beta 0 plus beta 1 gender. So what is the interpretation of beta 0 and what is the interpretation of beta 1? It is clear to you that is the intercept. Beta 0 is the mean wage for that category of which DI equals to 0. That is the female. And what is beta 1? Beta 1 is the difference of the mean values between, considering for whom DI is equal to 1 and for whom DI is equal to 0. Am I clear? It is very important. Just I'm telling it another time more. That is, you get the mean wage for the male is what? Beta 0 plus beta 1. Putting DI is equal to 1 into the equation. And what is the mean wage for the female? That is beta 0. So it is clear to you what is the interpretation of beta 0. That means look at the framing of the dummy variable. Di is equal to what? 1 for the male and 0 for the otherwise. Remind that when we framed the qualitative variable by such a way, the 0 is considered as the base group. So here the females are considered as the base. So what is the beta 0? That is the base salary of the base group. That is the female. And what is beta 1? It is the difference between mean wage considering DI is equal to 1 and the mean wage considering DI is equal to 0. That means difference of the mean wage between male and female category. That is the interpretations of the beta 0 and beta 1 term, which is given by, if we do it mathematically, this is given by this equation. Okay? Just 1 minute. So is it clear to all? Or if you have any questions, you can ask. The screen is visible, it is sharing. The screen is visible to all?
Yes, sir.
Okay. So now what we are doing to understand the effect of a qualitative variable, we introduce one quantitative variable with the qualitative variable. So we consider this equation by introducing another variable, that is wage is equal to beta 0 plus beta 1 into its x plus beta 2 into education. So we consider education as a variable. So how education is measurable? That is the years of schooling of the individuals. So it is a quantitative variable, that is how many years the individual, he or she, spent in the school. That is given by the education. So gender is a qualitative variable here because it is identified by the male and female. But education is a quantitative variable and education is measured by years of schooling. Okay. So we consider the relationship in terms of mathematics, in terms of statistical relationship as wage is equal to beta 0 plus beta 1 di plus beta 2, another quantitative variable x1i. But look, here the difference between di and x1i. Di is a qualitative variable. but x1i is a quantitative variable. You get the numerical values, numerical data set of x1i and wage. But for di, you get the information only he or she as a male or female. So di is equal to 1, like before we consider that female as the base group. So for them it is 0 and 1 for the male. You make it reverse also. You consider the male, for the female it is 1 and 0 for the male. Then the interpretations of beta 1, beta 0, beta 1 will be changed, what we discussed earlier. So here, look, if we find out the mean wage for the male category, that is di is equal to 1. If you just put here di is equal to 1, then what do you get? You get beta 0 plus beta 1 plus beta 2 into years of education, years of schooling. And that is what? That is the mean for male mean wage. That is beta 0 plus beta 1 plus beta 2 into xi. And if we consider the same expectations, considering di is equal to 0, then beta 1 into di term will be vanished because di is equal to 0. So only there will be beta 0 plus beta 2 xi. And that is for the female, this is the mean wage. So how the mean wage, what is the mean wage of the male category? That is the intercept beta 0 plus beta 1. Look at the male mean wage. What is its intercept? It intercepts is beta 0 plus beta 1. And its term with education is beta 2, which is its slope. And for the female category, the same intercept is only beta 0 and the slope is beta 2. So you find that is the mean for the mean wage of male category, the intercept is beta 0 plus beta 1. And for the female category, the intercept is beta 0. And slope of both the category are equal. So what actually in our theoretical implication means? It means a boy and a girl of same years of education, when they try to enter into a job market, at the entry point, they receive different wages because intercepts are different. But the slope, that is the growth of the salary, is same. That means if the boys get the first increment after 3 years, the girls also receives the increment, first increment after 3 years. But their intercepts are different. One is suppose starting with a basic salary of rupees 10,000. Another is doing the same kinds of job with 8,000. So there is a difference in intercepts and their slope is same. That is the mean wage for the male category is beta 0 plus beta 1 as we defined. And what is the intercept for the female? That is the beta 0. So slope function of both is beta 2. That means both are growing. What is the meaning of the slope? That is both are growing with, if education changes, how the wage behaves, that is given by the beta 2. Because x1i is what? Education. That means years of schooling. If years of schooling, if a boys or girls with an extra year of educations, what is their return from educations in terms of wage is same, both for the male and the female, because all these are equals to beta 2. That means difference of the intercept is there. For the male, the intercept is beta 0 plus beta 1, and for the female, the intercept is beta 0. So males are getting by beta 1 amount extra wages in compared to the female in this case, when you introduce education with gender into the wage function. So as a result, difference of intercepts of male and female, it is called differential intercept. That is, intercept-wise difference is there, and slope functions of both is equals to beta 2. So if we consider it in terms of the figure, how it looks like, suppose this is the male wage and the blue line is the female wage, and the red line is the male wage. So you find that both lines are parallel. That means they are creating the same angle with the considered horizontal axis. That is, both the slope functions are equal to beta 2, but they have different intercepts. One has beta 0 intercepts and other has beta 0 plus beta 1 intercepts, though they have same slope. So economic significance, what I'm telling you, that is when we include an education as a quantitative variable in the model, what we get, we found that both male and female with same years of schooling, same increase in wage, but differences in intercepts. That means a boy or a girl with equal amount of educations, their return from education varies by such a way that their same increase in the wage over time or for an extra year's increase in the education, and the intercept differentials are there. So both male and female with same years of schooling, different level of starting wages or salary, but the rate of increase of wages or salary is same. That means responsiveness of mean wage with respect to education is same across gender. That means across gender, the responsiveness of the mean wage, that is how the mean wage responds if education is increases by 1 unit, then that responsiveness is same. So incremental changes in wages due to extra education is same. So if we relax such assumptions, that is the mean wage with respect to education is different across gender, what will happen? So if we relax these assumptions, that is the returns from education, that is the mean wage with respect to education is different across the gender, that means education has some impact on increase in wage across gender, and that is the third case. That is the third case. First case, we are considering only a quantitative variable with a qualitative variable. Second case, we consider a qualitative variable associated with another quantitative variable. And the third case is this, that is where you consider the mean wage with respect to education is different across gender. That is called interaction qualitative variables and quantitative variables. That is, if there is interaction between a qualitative variable and a quantitative variable, that is interaction between dummy and quantitative variables, then we write the earlier equation in some twisting form. What is the twist? Twist is this. Look, wage is equal to beta 0 plus beta 1 gender plus beta 2 education. Up to this, it is similar with the model 2. But here we bring another term, that is beta 3, which is gender cross multiplied with education. This is called interaction term. Beta 3 is the coefficient of the interaction term. That is here, look, the number of variables remains same. That is, you get the wage data, you get the education data, and you get the information about their gender. Now, with these two variables, one is qualitative, another is quantitative, we framed a variable that is called interaction dummy, and that is the gender into education. Now, let us see what will happen for the male and female in these cases. So, we write in terms of the dummy variables, this is as beta 0 plus beta 1 di plus beta 2 education is termed as x1i plus beta 3 as gender is defined as di, and education is defined as xi, so it is defined as di into x1i. And the dummy variable is same, that is 1 for male and 0 for the female or otherwise. So if it is happened, the mean wage for the male category, what will be the mean wage for the male? That is, we know for the male di is equal to 1. So we put that all di values equals to 1. Then we get beta 0 plus beta 1 plus beta 2x1I. And if we, within the bracket, if we put di is equal to 1, then it becomes beta 3x1I. So actually, in form of intercepts and slope, we write the equation as beta 0 plus beta 1 as the intercept and beta 2 plus beta 3 as the slope. That means what is the effects on average wage of education. If education changes by 1 unit, by what amount on an average the wage changes for the male category. Okay, so this is the mean wage for the male category, and beta of which beta 0 plus beta 1 is the intercept and beta 2 plus beta 3 is the slope. Now the same thing for the female category. That is, if I am putting di is equal to 0 in the wage equation, what do we get? We get beta 0, then beta 1 di term will be vanished as di is equal to 0, and beta 2 xi, and beta 3 term is also vanished because di is equal to 0. So the mean wage for the female category is beta 0 plus beta 2 xi. So its intercept is only beta 0 and slope is beta 2. So its intercepts is this and the slope is beta 2. So look at the difference of the intercepts. Earlier in our model 2, there is difference in intercepts, that is beta 0 plus beta 1 and beta 0. It remains same. And now there is a difference in slope also, as well as that is the rate of growth of the salary between the male and female, that is beta 2 plus beta 3 and beta 2, which is earlier it was if all are equal to beta 2. For the male it is beta 2 and for the female it was beta 2. Now it becomes beta 2 plus beta 3 for the male and beta 2 for the female category. So what we get, that is differential intercepts. Earlier in this case, the intercepts for the male category is beta 0 plus beta 1. So looking here, this male category, that is the beta 0 plus beta 1. And the female category, the intercept is beta 0. So what is the difference? Difference is beta 1 plus beta 0 minus beta 0, that is beta 1, which is also same in our model 2. But now the differential slope is there. Earlier it is same as beta 2, but now it becomes beta 2 plus beta 3 is the slope for the mean wage of the male category, and beta 2 is the slope of the mean wage for the female category. So difference of the slope is identified as beta 3. So if we draw this thing, that is the case of interaction dummy, when we interact one qualitative variables with the quantitative variables, how it's framed. This is the wage line for the female category, whose slope is beta 2 and the intercept is beta 0. And now the male category, it is represented by the saffron line, and this is the intercept for the female category is beta 0, and the female intercept for the male category it is that is beta 0 plus beta 1, and the slopes of the two are defined as beta 2 and beta 2 plus beta 3. Just 1 minute, I have to attend one call. হ্যাঁ বলুন, একটু দেরি হবে যে, একটা আছে। হ্যাঁ আপনি কি বেরোচ্ছেন? ও ঠিক আছে যান হ্যাঁ। না আপনি যান, কোনো অসুবিধা নেই। হ্যাঁ ঠিক আছে। ও তাহলে ঠিক আছে। হ্যাঁ ঠিক। আচ্ছা ঠিক আছে। So the difference of intercepts and difference of slopes are identified. That what is the economic significance? That is, when we include education as the quantitative variable in the model with sex, we again not only we include education as a quantitative, new quantitative variable, we also interact it with education. So what we get, we found that both male and female with same years of schooling, they have the differences in terms of the intercepts and differences in terms of the slope. That means both the male and female with same years of schooling, they have different level of starting salary because intercepts are different, and difference in the rate of increase in the wage, wage or salary. So responsiveness of mean wage with respect to education is differ across gender, and female started with lower wage rate in compared to male, and the rate of increment of the wages of the females are quite less than the male category. So this is the thing what we get. Whether I should stop here or
Sir,
if anyone have any questions, because this discussion, just stop the sharing.
so participants, it depends on you.
If you have any questions or anything, because what is difficult for me, that is if I am make a lecture, theoretical lecture, it have some, I feel that you have some boring type of discussion. So by introductions of some mathematical relations, statistical relations, I try, that is I'm actually trying to make it some interest. That is how it is happening. And when you are dealing with qualitative research, you also have to incorporate some analysis like qualitative variables. Otherwise, it is not accepted, because what is happening today, that is even in case of social science research, they have to justify it. So justifications mainly depends on, that is, validity of the model, what you assume, and how the quality variable behaves, and what are their what are their returns. You have to estimate those returns in terms of quantitative forms. Then the modern research journals accepted the research work. So why in your theoretical research also, in your on qualitative variables, if you incorporate such kinds of discussions, it will make attractive and your publications becomes easy. So I think I will stop here today.
Okay.
Sir, this is Pandvinigani. I have a question to you.
Yeah.
Sir, the part where you have discussed, you told us that in case of dummy variable, we have to take one. If we have four, then we have to less one variable, then we'll take three variables for that.
Yeah.
So can you please tell me the reason that why we take one variable less?
Yeah, sure. Look, suppose our simple relationship like wage is equal to that alpha plus beta gender. Now you consider gender, you construct the model by such a way that is wage is equal to beta 0 plus or alpha plus beta 1 into d1. D1 is framed by such a way that it is 1 for the male and 0 for the female, plus another one beta 2 into d2, where in d2 you find that it is 0 for the male and 1 for the female. Then what will happen? Just go back to your Excel sheet in the data set. Suppose you collect the wage informations and you collect the sex informations. That is, what you write? It is 1, that means it is male, and 0 in place of female. Do you write it 1 in one column and its next column you write it as 0? That is, if I framing it by D1 and then it is D2, which one is male, that get one value, and which one is not female, that is the male, in terms of D2, that receives 0 value. So ultimately what will happen, if you frame by such a way, that is, there are the two categories like male female, one for D1 male is receives 1, and for D2 male is receives 0. What will happen? The sum of D1 equal plus D2 is always equals to 1. And if it is happening, then one trivial problems of econometrics will come that is called multicollinearity. That means a perfect collinearity between D1 and D2 comes, and our model is not accepted. Okay, that is the reason you have to consider only the number of, you have to introduce the number of dummy variables as per the number of categories minus 1. Okay, it is.
Okay, okay, sir. Thank you, sir.